I'm going to start to present the video generation software, SDK. So the goal is to allow developers to build video generators by leveraging state-of-the-art AI video, generative AI video models and mixing them, tuning them in order to generate a video corresponding to a particular use case. So what happens is that there is, as you may have heard, some improvements that happen into the space of video generation. So there is like a lot of providers, being like Sora, Runway, Pika Labs in America, but there is also Chinese open source models as the Xin Shanghai AI Lab model or Videocrafter 2 from Tencent. So there is actually a lot going on, and there is this slide is already outdated. I made it like last month, but there is already like 2 new improvements that were out since I made this slide. But there is also a lot of model and a lot of improvement, because there is not only video generators from text, there is also video generators from image. There is also models to do video transition, so to transition from one video to another in a smooth way. Video coherence models in order to have to take multiple videos and to make them the same team, to have the same style on it, to have some kind of coherence between many videos. Voice generation, character swapping, which is useful if you want to have the same character from video to video, etc., etc., quality enhancement. And all of these models that have a particular usage have a multiple can be provided by multiple providers. So for each of these cases, almost each of these structures that you see on the bottom of the slide have a version of it. So they say they are the same, but they are all a little bit different in reality, as they all have different parameters, new ways, other ways of being used, etc., etc. So what AI creator community is doing now is to generate a short video from one provider, and tune it with other providers, and do some post-processing on that, etc., etc. And there is multiple use case of video. So there is not only one usage of creation of video. So you can purely generate the videos that you will publish. You can also do a background of your podcast. If you have a text podcast, maybe you want to have some video in order to publish it on YouTube or something. Maybe you want to animate archive, to pre-visualize movie scenario, to create educational content to share internally into your company easily or outside of your company, etc., etc. So there is multiple ways, things to do, and so our tool, the goal is to match these models, so all of these models, to a particular use case. So we did with this SDK a mix of models that would generate exactly the videos that you want to have. So, but before to say what we do, let me show you a little bit where is the research and why the landscape of video generation is sort of fragmented. So, first of all, like maybe some of you already know that, but what is the diffusion model? So diffusion models are the models that are used for image and video generation nowadays. So the idea is to, instead of generating an image in just one step, so having like a prompt and then that will generate an image, the diffusion model will take an input noise, as you can see on the bottom left, and then generate it in each step, generate a little bit of the image, and then we will take the outputs, repeat it inside the model, and then it will generate a little bit more of the image, etc., etc., until we have the full image. So actually there is an hyperparameter in diffusion model, which is the number of times we're going to pass the image into the model. And so how do we train that? We train that by taking an image. We add some random noise to this image in order to generate the same image but with a little bit of noise. And the goal of the model, when it will be trained, is to predict actually this noise in order to be able to denoise the image. So if we change that with sufficient number of images, then the model will be able to, from pure noise, make little by little appear something. And of course, we can give other parameters to the model, like a prompt, a negative prompt, another image, etc., etc. We just need to add it as an input with the noise. So this is a long story short of a diffusion model. So this is used for image generation. And for video generation, what was done before was to have diffusion models, so same, but to generate keyframes of the video. So the model would generate like one frame at 0 seconds, one at 0.3, one at 0.6, etc., etc., by a diffusion process. So with multiple paths. So we would have a first model on that, and then we would have other models that would generate like the intermediary frames, because the video is just a bunch of frames for recording. So it's just the difference between the video and an image is that in the video we have like 12 images per second, 24 images per second. So the goal is to generate a bunch of images that are coherent between themselves. So, as a story. So you would have this, and then the second model would generate like intermediary frames. But the problem with that is that since the model that would generate intermediate frames, let's say between frame 1 and frame 2, is not aware of what has been generated between the other frames, then the experimental result was that there was a lack of coherence on that, because the frames that would be generated at the beginning of the video or at the end of the video would not have a link between themselves. So we'd have like, for example, in this example, we have a panda, so we generate a frame of a panda doing something, but maybe in the beginning of the video, the panda would like eat popcorn, and then at the end of the video, the panda would I don't know, like jump or like eating bamboo or something else. So in order to solve that, what was done is to generate all the frames at once. So instead of generating keyframes and then to generate subframes between these keyframes, generate all the frames at once. So generate like 24 frames for a 2-second video of 12 frames per second, etc., etc. Problem with that is, of course, that each frame needs to be aware of all of the other frames. So in order to generate one new frame, you need to pass information to the diffusion model about like all of the other frames in order for the model to be able to generate an image that will be coherent with the other images. So if I'm moving my hand like this, in order to know that the next frame needs to be my hand like this, you need to know that my hand was here and here and here and here and here before. So there is a problem of compute cost with this approach, and this is actually why most of the video models nowadays, they generate 2 seconds, 4 seconds, 10 seconds. Sora managed to generate 60 seconds, but with a lot of GPUs. So there is this problem. And to go back on a little bit on Sora, so Sora used also this technique that we generate it all at once. Their innovation is, of course, to have more GPU. It's OpenAI, but also to use like raw data. So they use raw data from the data, so non-modified videos. So they use video from different formats, different kind of recording, etc., etc. And they found the model would generalize better. Of course, they trained a lot more, so this is why it worked. And it worked also because they used, instead of CNN, of convolutional neural network, which is a technique that's used for image, for artificial intelligence in image, they use transformers, which happen to be better, and which happen to support to have data from multiple formats. Because in a transformer, you can give, it's much more flexible on the kind of input data that you can give. So there is a problem with the approach. So with the first approach, there is a lack of coherence. With the second approach, it's either a limited video size or costly. So it would cost like I don't know, $10 or $15 for each video to be generated, and the video would not always be a good one. So we need to have several tries. So there is a problem of business model, and it's difficult also to control what is generated. It's the same with image models. but with image model, you can try and retry and retry. This is actually what is done in the image generation tools like Midjourney, like that we all know. So what we propose is an MLOps solution to be able to orchestrate and fine-tune all of this model, and then to stack all of this result together in order to implement video use cases while decreasing the energy requirements and the cost. So by having like multiple open source small models that would like be working together and that would be more controllable and less costly to run. So more controllable. Why? So this is an example pipeline that we are building for an advertising agency. So we would first have an LLM that would generate a scenario. So and on each of for this scenario, it would generate like multiple scenes with the cinema vocabulary. And for each scene, you would have the description of the scenes and the transitions and some things specifics about like the camera movement, etc. So for each scene, we generate a video. And in order to be sure that the video are the same, we do a site transfer model. We apply a site transfer model in order for the video to all have the same style. Then we do character swapping in order to be sure there is the same character. And then we add a transition model in order to have a coherent transition between the frames. So what we're working on is to improve that, is to do generation from image. This is the feedback that they gave us. Actually, Runway do it also. So you would just put an image in order to animate it, and an image with the theme of your brand or something like that. So there's multiple things to do. So this is the first thing. And the second thing is that this approach allows us to generate for it's less costly to generate that. So instead of $15 or $10 or whatever the cost of big models are, which costs that are not public, there is only speculations, we cannot go on that. But for us, a video can cost like $2, $1 for a long video of like 60 seconds. So there is really room to save money, but also to try and retry new formats and to easily experiment at a reasonable price. Because of course, you will not make one try, you will make, 100 try. If you do 100 try, it will cost you only $100. So if the video costed you $15, with 100 try, it will cost you way more. So all building tools, as I said, allow to synchronize and orchestrate all of these models in order to implement these use cases. And what we provide on top of that, so it's a easy SDK with client libraries, with an object model. So you just create new video with these models, with these parameters, and then you can generate the video. We host the models, the open source models, or you can call like commercial video generators. But you don't need to take care of that, because what you just need to do is to create an object, and then the SDK we call the cloud model, and then automatically mix the output of all these cloud models with the same format, with the same frame rate, with the same audio tracks, etc., etc. We offer lifecycle management tools and quality monitoring, so being sure that the generated video is answering quality metrics that are from the research, because there is ways to judge if a video is of good quality or not, and it's automatically implemented. This allows you to do one, drift detection, but also to look if you make a change, if the quality drops, and because if you make a good generator, like most of the video will be good, but it's impossible with generative AI to only have good result. What you can do is to set up a threshold, and if the metric is under the threshold, to just regenerate the video, so drop the bad video automatically. So advantage of that, so purpose built video generation, high deployment and update velocity, closed and open source models that can be used seamlessly, computationally efficient, and since the models are stored in Docker and Kubernetes, it's portable. So you can either use all cloud products, or you can host your models into your infrastructure and to some private cloud generator. So to go a little bit more into the techniques, into the specificities, so what we did, we used software engineering design patterns in order to be able to build this generator. We have a prompt factory object that would generate the script, actually. So all the prompts from for all of the videos to be generated. For each of the videos, transition, etc., you can parameterize them with some, for example, the style, or for example, like any tunings that you would want. And you can apply transformation model on it, same with an object model, a transformation model like character swapping or the other kind of, any kind of transformation that exists now, but maybe in the future there will be new transformation and we'll add them to the SDK. As I said, like the models are stored into the cloud. We store them into our cloud, but you can also store them into your cloud. Then you have the advantage of course, so you benefit from hardware cost reduction. And we all know the advantage of cloud. The cost is proportional to inference size, etc., etc. And then we try to use, if there is an open source alternative, we try to use always this open source alternative. So this allows us to pay less first, to not pay like proprietary services that cost more, but also to be less disruptable by new video generation technology. We don't make models. We can tune and make this one, but if we focus on the generation of the pipeline writing, then when there is a new model, you don't need to rewrite your own pipeline. You can just like switch the model and have exactly the same pipeline. And then look, if you switch the model, of course, if the quality decrease or not with the quality monitoring tools. So I just can show you a little bit how is the code. And it's really yeah. So this is an example of a code that we made for our website. So we would use like a prompt factory object that will create prompt from text. We can also create prompt from sound, and we will soon add image generation. So then we have all the prompt of the videos. Then we create a video composite object in order to plug all of the generated video into one object. Then for each of the prompts that we call subtitles that will be generated by this object, we generate a text with a raw text-based video object. We build it with some parameters that allow to tune what the video will be about. We generate a second one with other parameters in order to add some variance. It's a way to generate that, but we could totally change it. It's very modifiable. This is the goal of the SDK. Then we generate a transition. It's a subclass of a transition object with the same transition, and that is a transition model that is actually the state of the art. Maybe in 1 month it will not. We will just need to change the object when this will happen. Then we append all of these videos to the current object. Then we build this video, and automatically our tool will mix all of that, standardize everything. And then we append this video that we generated into one loop to the global video. And when the loop is finished, when we generated all the video, all the transition, etc., we just do the same. We build the final video and we upload it into where the user needs to see it. So yeah. So this is more or less our object. So from factory, video composite, video transition, imported video, prompt-based video. We are adding new objects maybe not every day, but every week. And we are looking for beta testers. So if you want to beta test, you can talk to me after this talk. Thank you very much. I'm going to just show you an example of a pizza advertising video that we generated actually through this suite.
Craving perfection? Indulge in our mouth-watering pizzas. Made with the finest ingredients and baked to cheesy, crispy perfection. Satisfy your cravings with every delicious bite. Order now and experience pizza bliss.